This video will help you take notes for the two sections we're going to talk about today. The first one is coordinate geometry number 1, midpoint, and section 1.2, finding angles. I'll ask you to take out your notebook. Make sure you put these two sections in your table of contents, along with today's date and your page number. And as you're taking notes, remember, push pause frequently so that you can write things down. Rewind, back up, watch it again, and please ask questions at any time. So section 1, coordinate geometry. Typically, when we want to find the midpoint of a line segment, let's say, we would grab a ruler, you would measure it, and you'd find the length that would be half as much, right? The middle point, the midpoint. When we talk about coordinate geometry, we're talking about a line segment on an XY grid. And finding the midpoint is finding the coordinates of the midpoint. So, if we have two endpoints, let's call them x1, y1, x2, y2, the coordinates of the midpoint are x1 plus x2 divided by 2, y1 plus y2 divided by 2. So then let's take a look at an example. Let's say line segment AB has endpoints -8, 5 and 3, -6. Find the coordinates of the midpoint AB. I would recommend you pause the video now, try this out on your own, and then watch through to check yourself. The x-coordinate of the midpoint should be from -8 and 3, right? The x-coordinates of the endpoints. And so we'll sub those into our midpoint formula. For the y, we'll take 5 and -6. We'll sub those into the midpoint formula. So we have an x-coordinate of -2.5 and a y-coordinate of -0.5. It's worth noting that, take for example, in the x-coordinate we did -8 plus 3. If we did 3 plus -8, we would still get the same x-coordinate. And likewise, if we switched around the y's, we would get the same. So with the midpoint formula, it doesn't matter which you choose to be x1, y1, whether it's the first or second endpoint, just be consistent with yourself. Now let's move on to section 1.2, finding angles. I think it's safe to assume we all know what angles are, but just in case, let's define this very clearly. An angle is formed by two rays that share a common endpoint. So I'd like you to draw yourself an angle. It can be acute or obtuse. I made this angle and I named it TAP. Please note that whenever you have an angle, there's a vertex. In other words, the vertex is the corner of the angle, and there are two sides. There are a couple of ways to name this angle. We could name it angle TAP. So for example, you start at T, you end up at A, and end your angle at P. You could also call it angle PAT. Or, because this angle only has one vertex, we could also call it angle A. Next, I'd like you to measure the angle that you created. So pull out your protractor. If you're unfamiliar with the protractor, pause now and read through these 4 steps, and feel free to ask questions to help you out measuring your angle. My angle ended up being just about exactly 60 degrees. So even though I'm tempted to say that the measure of angle A equals 60, I know that because of human error, I'm not going to say that it is exactly equal to 60. I'll say instead that it is approximately equal to 60 degrees. We have a couple more definitions. One, we would say two angles are congruent if they have, if and only if they have the same measures. So let's take a look. We've got these two angles here. Please note those new congruence markings. We've got the red arc with the little red tick mark in them. So now we could say that angle NBC is congruent to angle FOX, or we could say the measure of angle NBC is equal to the measure of angle FOX. And then one final definition, angle bisector. Bisector, remember, is cut in half. So an angle bisector is a ray that contains the vertex of the angle, contains the corner, and divides the angle exactly in half. So here we have a picture of an angle bisector, and we can say either, well, we can say ray CD bisects angle ACB, and we can also say that angle ACD is congruent to angle BCD. I know that's true because of those green congruence markings that I've included.